I have plenty of slides. I try to go through them quite fast, and if there are questions, we can come back to these and a continued discussion after the slides. So, hello everyone. This is the title and a little bit more of the content. First, I was thinking to present a little bit of the history of biodiversity monitoring in Finland, current situation in Europe as well as in Finland, and then say a couple of words about the future plans in the end of the talk. That's the slide what I have been using quite a lot recently, and it presents on the upper part different in situ monitoring schemes developed and established in Finland to monitor environmental change and biodiversity. Below, you can see development of the different remote sensing satellite programs, which are currently more and more important also to fill the gaps and provide information for different monitoring schemes. So the oldest ones are the visibility depth of the Baltic Sea that was started already to be measured 1905. The visibility changes of the Baltic Sea across the Finnish coastline. The National Forest Inventory is one of the oldest programs, I think, in the world also, but also quite well established, and provides, of course, relevant information of the changes of forest structure and forest biodiversity. But then towards the recent decades, there are more and more emerging species monitoring schemes which has been established. But the challenge is that there hasn't been really strategy, or there have been ad hoc for different kind of needs and purposes, one by one, and no one has been really overseeing the whole landscape of the different monitoring programs, which today provides, of course, challenges, not only in Finland, but also in other countries. If we look a little bit of these reasons how some of these schemes were established in Finland, so forest industry was one of these purposes why national forest inventories became crucial for Finnish economy and society. Also during the last 100 years and decades, Finnish population has been really much consuming fish stocks of the Baltic Sea. For example, Baltic herring was really important source of food still until the end of 70s. Nowadays, I think its importance has been, of course, decreasing, but the reason was that there were changes of the fish populations, so there was really need to establish monitoring schemes to understand these changes, not only for the commercial purposes, but also for the stability of the society. Then, if we go forward towards the more recent times, algal blooms of the Baltic Sea has been increasing during the last decades. That's mostly because of the natural load from the agriculture, but also from the different point sources. And in Finland, originally 70% of the country was marshes and peatlands, which has been heavily ditched for the forestry purposes to increase forest growth. And that has, of course, had a significant impact for the ecosystem processes, but also changes in the vegetation all over the Finland. And the chlorophyll A monitoring scheme was actually established in the end of the 1970s. Maya butterflies were observed to be decreasing several populations because of the changes into vegetation, so they were started to be monitored 1991, for instance. So anyway, that's the situation, but the challenge has been that there hasn't been coordination, no strategic planning, how to link different monitoring schemes together. There hasn't been really think about shared data management, neither standards or protocols. So they are quite nationally specifically designed without thinking what's going on with, for example, in our neighbor countries or across the Europe. Couple of other slides still emphasizing this last 100 plus years of the biodiversity observations in Finland. This is from the paper by colleagues Ruslin and Laine working in Helsinki University. They have been compiling Finnish species observations together for the different analysis of ecosystem changes. And the more reddish color, the more observations there are from the different monitoring schemes. And this has been also overlaid then over the Finnish map to show where the most observations are gathered in different hexagons. So there are still some areas which are quite pale, and of course the big cities and their surroundings are emphasized with observations. When we started to think a little bit more strategically, this Finnish situation of how to improve the coordination and data availability and the monitoring scheme overall picture, we have been quite heavily engaged with GeoBond initiative and the ideas of the use of essential biodiversity variables as a framework to cover different dimensions of the biodiversity in different monitoring schemes. So I think this is quite well-known concept, so I wouldn't go deep in details here, but just to mention these 6 key categories: genetic composition, species populations, species traits, community composition, ecosystem structure, and ecosystem function. And in one of the previous papers, we also analyzed how currently used Finnish monitoring schemes could provide data for these different EBV categories. And species populations is, of course, the best covered group of the EBVs, while, for example, genetic composition is mostly lacking. Traits are quite rarely measured, and community composition, ecosystem structure, and ecosystem function are also not optimal, I would say. There are some programs, but not full coverage of the different needs. So EBVs basically are following this pipeline, that there are raw observations which needs to be harmonized, put together in a different data cubes to provide data products which are then meaningful for different decision-making purposes across the society. And they could be, for example, be the basis of the indicators for different international agreements. So in theory, this EBV, it's a great idea. It really provides good approach to try to think about biodiversity monitoring schemes, but in practice, it's pretty challenging. And operational examples, they are rare or missing in most of the countries at the moment. However, in Europe, there was a project called Europa Bond, led by IDIV colleagues from Germany. They were defining 84 different EBVs tailored for the European purposes. And pretty much these species-related EBVs were emphasized in this exercise. But anyway, that was really first thorough thinking through the several expert workshops, what could be the best kind of set of EBVs to serve European biodiversity monitoring needs. In the same project, there was also analysis done what kind of gaps there are currently, what comes to the different species monitoring schemes. Here in this picture, in a glance, you can see terrestrial monitoring schemes with the green color, freshwater with the yellow, and the marine-related monitoring schemes with the blue one. And if you check these space and time classes there, you can see that there is quite a lot of things missing. And of course, species populations are maybe the best represented, but anyway, that's the current situation across the Europe. I also would like to emphasize that on the national scale, there's often quite a lot of detailed demand for biodiversity information, for example, for local municipalities or private sector, to get the data what is then especially explicit and could be used for different purposes, not just for national reporting of the indicators for the international agreements. These European colleagues, they also published recently a paper, which I recommend you to check through. And one of the key recommendations was this establishment of European Biodiversity Observation Coordination Center, EBOC, which I heard that you had already a talk, so I don't spend more time on that. That's ongoing pilot project, 3 years, trying to cover 6 different EBVs piloted across the member states. And that's then serving needs of the European Commission, so that it's pretty much top-down approach. But I would like to also emphasize this Biodiversa Plus, which was mentioned in the introduction, because that's more bottom-up. So it's the European partnership for research funding agencies previously, but in this current Biodiversa Plus, there has been also ministries of environment or environment protection agencies involved. And one of the major new components has been this biodiversity monitoring activities. So work package 2 is focusing particularly for these biodiversity monitoring activities, and we have a quite dense program ongoing. So now over 4 years has been develop this kind of cooperation, and that will continue until end of 28 at the moment, and hopefully after that there will be continuation for Biodiversa Plus in a long run. So this is building on the ongoing national monitoring networks and building transnational elements on top of these baselines. 41 countries, 83 partners, and total budget up to 800 million euros over these 7 years of cooperation. A couple of key concepts of Biodiversa Plus, which are linked with this EBOC idea, are the national coordination centers, which relates for the webinar series where we are here, and then the thematic hubs. And in Biodiversa, we have been thinking that national centers are crucial because that's the lowest level of the governance, who are funding and steering a lot of national monitoring needs, and they should be aware of the different monitoring initiatives and networks ongoing in their country. And it's pretty hard anyone else rather than a national experts to get an overview what's going on with the different monitoring schemes. So idea of the Biodiversa is to provide support and coordination and tools and ideas and cooperation platform for this kind of transnational collaboration. Thematic hubs are a little bit more independent, I would say, because they are more related on the volunteer basis networks. I jump over these slides. So in Biodiversa, there was a mapping done, and over 60 different biodiversity monitoring communities were recognized across the Europe, covering, for example, regional, habitat, or different taxa. And you can see an overview here what kind of different thematic groups there are already. Some are more advanced, more organized, and others maybe need a little bit more support. And the basic idea has been that through this kind of thematic expert networks, it's the best way to also develop harmonized protocols for different monitoring schemes across the Europe. In Biodiversa, we have been also investing for different monitoring pilots, 9 pilots altogether, covering different experts from different countries. So we have invasive alien species, soil, automated biodiversity monitoring stations, rockfish, and a habitat pilot. And recently, we also started a couple of new ones, ponds, forest, and insects, which were just launched in the beginning of this year. And all this will be running and synthesized towards 28 when the Biodiversa Plus is coming to the end of the current program. I also would like to mention this global initiative and idea of the global biodiversity observation system, what is needed and missing at the moment. This initiative is mostly coming from the GeoBond network, and the basic concept and idea is that biodiversity observation networks are national and they should be built on national observation networks, but there could be a lot of cooperation and synergies to get this data together for different trend analysis, and EBVs in that sense provide a good way of harmonizing different national observations for different regional or global or local analysis of the biodiversity chains. And that's definitely needed to support effective decision making. And one of the analogies is coming from the climate system, that for the climate community IPCC, there are global observing systems in place, but for IPBES, such a system is currently still missing, which really gathers data together and makes this analysis. Okay, but let's go then for the Finland. So what has been happening in the Finland during the past years and maybe I would say last decade? So we had a Finnish Ecosystem Observatory project which finished 24, and during that we were able to go through this Finnish landscape of different monitoring schemes, and a few reports were published during the project, for example, roadmap for implementing national eDNA and other molecular monitoring methods in Finland. Then there was a spin-off project which went through and analyzed the systematic species monitoring programs in Finland, which altogether were found 90 different species monitoring schemes. And then in general, we were trying to also think about how the different novel methodologies could be supporting ongoing monitoring schemes. One of the key outcomes was the Finnish Nature Information Hub. You can find it from luontotieto.fi web pages, and everything will be there also in English. So there are 3 elements: data search, overview of the descriptions of the current monitoring schemes and methods, and then a little bit more advanced indicators and applications for biodiversity data for different purposes. In addition, we managed to establish a national coordination group for nature information, which covers 17 different organizations, data providers, data users, and it's divided in 4 different sub-thematic groups: habitat and species monitoring, information interoperability, research and adoption and application of new methods, and the use of nature information. And all these thematic groups are meeting a few times a year, and then the coordination group together comes also together 2, 3, 4 times a year normally. And one of our proposals has been that there should be investments for national monitoring program in the long run, and thinking about the long-term future development needs in Finland that link with the international ongoing processes at the same time. So basically, data search, monitoring and methods and nature now. I will jump over this and recommend you to visit the webpage, but just to give a little bit of the taste what is in there. So for example, this monitoring and methods, it's divided into different areas. If you click current nature monitoring schemes, for instance, you will get a window of 4 different categories: species monitoring, habitat monitoring, ecosystem progress monitoring, and genetic diversity monitoring. And if you click, for instance, species monitoring, you will get first an introduction in general terms, what species monitoring means and what kind of methods they are used. And then in the bottom, you can find different taxonomically organized groups, which if you click the plus, you will get an overview all these monitoring schemes related to these categories, and also a little bit more information. For example, for the plants, you will get a link for the available web pages and all the plants related monitoring schemes. We hope that this is comprehensive. If you find that something is missing, please let us know, and I will try to add it there at the moment. Same for the invertebrates, also all these invertebrates related monitoring schemes listed there. Contact point and a link to the web page are mentioned. Then for the vertebrates, that's the most diverse because, as said, it covers 90 different monitoring schemes. Some of them are here, not all of them. But yeah, that's just a glance to get like an overview. And then we have a fungi, and also some of these which are covering various species. So they are there in the end under this category of several monitored species groups, monitoring schemes and surveys. Little in-depth for the species monitoring related themes from the report of colleagues Päivi Sirki and Ari-Pekka Auvinen. They made a thorough analysis what kind of information could be get out from these current monitoring schemes in this report. Unfortunately, only in Finnish, but hopefully this information will be available if you're interested. So, for example, they were going through mammals, birds, insects, and so on, and species categories, a list of a number of the species which have at least one observation of a particular species per year in Finland. Then number of species where distribution evaluation is possible to do for Finland, the number of species where abundance evaluation is possible to do for the Finland, and the start of the scheme year, and also divided this information across the realms and taxa. So terrestrial is the most numerous group. Marine is light blue, freshwater red on the left side, and then vertebrates is the blue on the right, on the green on the right side, and blue is invertebrates, red is plants, and orange is several taxa together. Then if you go for habitat monitoring, you will get an overview of the current habitat monitoring schemes in Finland. They are not so numerous. We have National Forest Inventory, then some kind of traditional landscapes of protected areas, reindeer pasture inventory, and nationwide monitoring of ecological status of surface waters, and a WELMO program for coastal and underwater marine biodiversity monitoring program. A terrestrial habitat monitoring program is under construction and should be starting soon. This next summer will be piloting year for this program. Ecosystem process monitoring is also included here. Here it's basically divided for nutrient load calculations and environmental and air quality measurements of intensive stations. Then, of course, research infrastructures are quite often providing relevant ecosystem process related information in Finland. Then I also would like to mention this genetic diversity monitoring, which is maybe the weakest at the moment. There are some related for some species like wolf, for example, or some game and fish, which are economically important for Finland. But then there's also quite intensive progress ongoing for developing genetic diversity monitoring scheme and program for Finland. Apo Kahilainen is a colleague who knows about that if you are interested to discuss more. In addition to that, there are also overview of the different monitoring methods. Particularly, I would like to highlight remote sensing and eDNA because these are maybe the most advanced, which has the highest technical readiness level for operational use for monitoring and supports quite many monitoring schemes, which were mentioned earlier. So you can also check what is told about these methodologies. There we have tried to categorize them in a very basic way to give an overview for anyone who is not expert in depth of these kind of methodologies to start and get linkages for other web pages where more information is available, how these kind of methods could be applied. Just to mention also, there was one recent exercise together with Japan colleagues to go through national databases. So this Luontotieto is mentioned there on the right side as well. What kind of data is available if a country would like to develop EBBs following these international pipelines and recommendations. So that was just highlighting where there are gaps, and the community abundance and trade diversity, for example, are the ones which have currently quite weak data possibilities. Finally, I would like to also mention that while the Finnish Ecosystem Observatory was a project in the beginning, we have been thinking that there should be actually national research infrastructure, something like that, which gathers different types of the observations and then provides a platform for harvesting, integrating and modeling these kind of data together to provide services for researchers, but also for society. And that, of course, needs different digital infrastructure to run all these processes, and quite heavy computing is often needed because some of the data sets are really big. One of the challenges with this kind of establishment has been that there is not really an international counterpart for this kind of systems. That has been a criticism what we got for the evaluators of the proposal. So there is not a similar counterpart on the S3 roadmap. GBIOS is still just on the idea, not really operational. So it's a little bit chicken and egg problem that who should do first and what, but this is something what definitely needs further thinking to provide wall-to-wall biodiversity ecosystem data which supports society at a large scale. Just a couple of highlights. I think we are running out of time, so I just highlighted one of the paper where we, together with colleagues led by Tiina Laamanen, did an analysis of the systematic literature review of 420 articles, how eDNA and molecular methods are used for biodiversity monitoring schemes. You can see they are quite high on the technical readiness level, so really ready for the implementation, also across the different taxa. But the challenge is that if this would like to promote it more, there definitely needs to be standardization applied also for these methodologies, and there's quite intensive network German Finnish colleagues actively promoting this kind of ideas across the Europe. So I strongly support you to check out this if you are interested. Then finally, a glance of these different possibilities of remote sensing. So European Space Agency is heavily supporting biodiversity related applications at the moment. There are different kind of sensors which can provide really a lot of new observations. I would say they are still underutilized for operational biodiversity monitoring. Hopefully in the future, they could be better integrated in these different national monitoring schemes in Finland and elsewhere in Europe. In Finland, we have been, for example, trying to think how Sentinel data could be used for annual monitoring of the hydrological condition, for example, Apamyers, which is a nature directive habitat type, quite typical for Finland. Colleague Tytti Jussila and others made a paper about the methodology, how it could be used based on the water table level seasonality measurements, which you can then run in time and get nice time series based on this kind of new data. And the good thing with this is that you can really then integrate it with the restoration initiatives. For example, here you can see one Apamyer with and heavy ditching. These blue lines surrounding the protected Apamyer are the forest ditching, which was shown in the beginning. So that's one of the key of the restoration initiatives in Finland at the moment, how to improve conditions of this kind of connected ecosystems in the long run. And the Apamyers are quite diverse in Finland, and they are really a key habitat. So it's quite difficult without remote sensing to monitor these possibilities. Then we have been also working more with the science-related schemes to think about how to use different remote sensing applications and AI together to detect some rare phenomena like occurrence of aspen trees in the Finnish boreal forest or dead wood. A couple of recent papers by Janne Mäyrä, colleague, about this, which if you are interested, recommend you to check it out. Also to estimate the volumes of the dead wood and provide wall-to-wall maps of these species. Final slides, future needs, what I would like to mention. Everything else but species. Species is still important, but there definitely needs to be more cooperation across the genetic diversity traits, community composition, ecosystem structure and functioning, and then filling these gaps in space and time, taking better into account uncertainties, as well as connecting to the drivers of change. Final slide, in Biodiversa, we just last week organized for the first time European Biodiversity Monitoring Week, by 1 week 26, that was in Montpellier, France. And there was an announcement that the next one will be in Finland in May 28. So I recommend you to book this week already and prepare to visit us, and welcome to check this beautiful archipelago sea of Finland. With that, I would like to thank my colleagues and the audience and many others, maybe not highlighted here. So thanks for the interest and happy to continue with discussions.